American buildings consume 40% of the nation's energy. They use 72% of our electricity and emit 38% of our carbon emissions. The U.S. Department of Energy's Building America program researches ways to improve the quality and energy efficiency of new and existing homes, with a goal of reducing average home energy use by 40 to 100%. The benefit of that research is now being offered to homeowners across the country through another DOE project called Residential Deep Energy Retrofit. The Pacific Northwest National Laboratory is managing this research project for the U.S. Department of Energy and is one of several research partners across the country conducting the actual research with the objective of better understanding the energy and economic implications of home energy upgrades. Results of deep energy retrofit research on pilot home projects throughout the United States is demonstrating that homeowners can save 30% or more on energy bills while improving the comfort, safety, health, and durability of their homes. You, a homeowner, can benefit from this research by scheduling a home energy checkup with one of PNNL's research teams. A home energy checkup is like a medical exam, but for a house. The research team will diagnose the conditions in your home that are affecting safety, health, and energy waste, and then make recommendations for repairs and upgrades that will improve the comfort, safety, whole house energy efficiency, and durability of your home, while trimming your energy bills. To learn more about these programs, visit the websites for the Building America program and the Residential Deep Energy Retrofit project. A residential deep energy retrofit begins with a home energy checkup. The home energy checkup begins with a homeowner interview. A member of the research team will ask you basic questions about your home's condition and see if you have any specific concerns. This information will give the team important clues about the potential problems they may find during the checkup. The team will also ask you to provide the last 12 months of your energy bills, which you can obtain from your utility company if you have not kept your monthly billings. This information provides real data for analyzing your energy consumption throughout the seasons and determining whether the bills are higher than the average for your community. During the initial home energy checkup, inspections and tests are performed to look at the existing condition of your home. The team will perform outdoor and indoor inspections of your home, including health and safety testing. Outdoors, the team will perform a walk-around to inspect the exterior of your home and the yard for obvious health and safety issues. Is the paint peeling? Is the siding loose or wood rotting? Are there signs of mold or moisture damage? Are there drainage problems? Does the home have gutters, and are they operating properly with downspouts running away from the house? The team will measure and record construction details of the exterior of your home, such as the size of the house and foundation, the number of windows and their size and condition, the home's orientation to the sun, and the location of shady areas. If the home uses natural gas, the team will check the meter and gas line for leaks using a combustible gas leak detector. If any leaks are detected, the checkup is halted and the utility company will be contacted to fix the problem before the inspection can proceed. Health and safety are top priorities in PNNL's Residential Deep Energy Retrofit upgrade. The condition of the roof and chimney is inspected. Is the chimney high enough to properly vent combustion gases? How many vents are installed in the roof and where are they located? Do the dryer and kitchen and bathroom fans vent correctly to the outside and not into the attic? Inside the home, the team will conduct a walkthrough visually inspecting the home for any obvious health and safety issues, such as the presence of lead paint, frayed wiring, evidence of rodents or termites, combustion items placed near fuel sources, or any other possible hazards. A team member will suit up and check the condition of the crawl space. Does it have a dirt floor, or is it sealed with polyethylene plastic to block water vapor and soil gases from entering the house? Are there signs of moisture problems, standing water, mold, or mildew? If the home has a basement, are there air leaks around the rim joist? Is it insulated? Are there signs of moisture damage or mold? The team will inspect the attic, Are there signs of moisture damage or mold? What type and level of insulation is used? What is the condition of the electrical wiring? Is it new or the old knob and tube style of wiring? Are there signs of air leakage around recessed can lights, attic access hatches, flue pipes, and where the ceiling connects to the top plate? Dirty insulation is a sign of air leakage. Your home's insulation will be inspected in the crawl space or basement, in the attic, around the ductwork, and in your walls. To determine the type, amount, and condition of your wall insulation, the team will need to remove a light switch plate to see inside the wall. If that isn't possible, they may ask to drill a small hole at the base of a wall and use a video inspection scope to view the insulation and take a sample to determine whether or not it contains asbestos. Ductwork carries heated and cooled air from the central furnace and air conditioner to the registers throughout the home. The team records the location of the ducts and examines their condition for damage or disconnections, signs of air leakage, the amount of insulation around them. Dirty insulation around ducts indicates air leakage. Windows and doors can make a significant contribution to the comfort of your home. Are the exterior doors wood or metal? Are they insulated? Are the window frames wood, aluminum, or vinyl? Do they have single or double pane glass? Is there weather stripping around the doors and windows? Can you feel a draft around the edges? Do the frames show moisture damage? The team will use this information when compiling recommendations for upgrades to your home. Bathroom, kitchen, and laundry room exhaust fans remove excess moisture and indoor pollutants at the source. The team will inspect the fans to make sure they are working properly and venting to the outside. If the fan has enough suction power to hold a tissue, it passes the test. Lighting accounts for an estimated 15% of electricity used in the typical American home. One of the simplest upgrades a homeowner can make is to replace old incandescent light bulbs with new compact fluorescent lights that use 75% less energy and last up to 10 times as long as the old bulbs. The team will note opportunities for switching to CFLs or LEDs. The team will check your heating, ventilation, and air conditioning equipment and your water heater for safety. They will note the model and serial numbers, year manufactured, and the condition with the goal of identifying equipment that should be upgraded for greater energy efficiency and comfort in your home. During the initial walkthrough, the team will note obvious air sealing opportunities such as holes in the house, gaps around recessed can lights, drafty fireplaces, and holes around plumbing. These gaps and holes can also provide pathways for bugs and rodents to enter your home. A well-sealed home with planned mechanical ventilation is the most energy efficient and healthy home. The age and condition of the major appliances in your home will be evaluated to determine opportunities for upgrades that provide greater energy efficiency. If your home has combustion appliances, the team will conduct combustion safety testing. Combustion appliances include gas, propane, or kerosene furnaces, water heaters, clothes dryers, cook stoves, and fireplaces. Homes heated by gas, oil, or wood boilers, or pellet or wood stoves, and wood-burning fireplaces also require combustion safety testing. If your home has all-electric appliances, the team can skip these tests. Combustion safety testing begins with gas leak detection. Outdoor and indoor gas lines are tested for gas leaks. The gas oven and range are tested for higher than acceptable gas levels in the air around the stove. If the gas level detected is at the top of the standard considered a safe level, the team will advise the homeowner to install a carbon monoxide detector and recommend servicing the appliance. If the gas level detected is higher than the safety standard, then the unit must be turned off and serviced before using it again. If the water heater and furnace are fuel burning, the team will check the flue that carries the combusted exhaust gases out of the house. It should be in good working condition and have a proper slope to expel gases from the home, at least a 1/4 inch rise per foot. The team will check the furnace filter to determine if it is present, clean, properly sized, and properly inserted. They will also look for evidence of flame rollout, which is a significant fire hazard and a sign of backdrafting. Old fuel-burning water heaters, furnaces, and fireplaces are susceptible to backdrafting because the equipment relies on buoyancy to carry the used fuel up the chimney and out of the home. If the home becomes depressurized because the exhaust fans and clothes dryers are pulling more air out of the home than is being replaced, the combustion byproducts can spill back into the home instead of out of the chimney. Some combustion byproducts like water vapor and carbon dioxide are not harmful, but others like carbon monoxide can be deadly at high concentrations. To determine if backdraft is occurring, the team will depressurize your house and test your combustion appliances. First, the team will establish and record the baseline air pressure in your home with all appliances and exhaust fans turned off. Then, to depressurize your home, they will close all exterior doors and windows to make the house as airtight as possible, and then turn on all appliances and exhaust fans. When the house is as negatively pressurized as possible, the team will test each combustion appliance for three things: spillage of flue gases, flue draft, and carbon monoxide levels. Based on the results, the team may recommend repairing an appliance, replacing open combustion appliances with sealed combustion appliances, or installing a mechanical supply of ventilation to bring fresh air into the space. If carbon monoxide levels for any of the appliances exceed current safety standards, the team will stop the checkup and will not proceed until the appliance is serviced and the problem is corrected. The blower door test measures how much air is leaking out of a home. The test can also be used for finding leaks and for retesting the results of all air sealing fixes. To prepare for the test, the team will close all windows, open all interior doors, turn off the thermostats on heaters and water heaters, and shut fireplace dampers or wood stove air intakes. If there are ashes in the fireplace or wood stove, they will be removed or covered with damp newspapers so they won't blow out into the home during the test. The blower door equipment consists of a frame and flexible panel that fits into an exterior doorway, a variable speed fan, and a manometer and hoses for measuring airflow. The fan blows air out of the house, lowering the air pressure inside. When the air pressure inside is lower than the air pressure outside, air flows into the house through unsealed cracks and openings. With the blower door operating, the team can detect the air flowing into the house by simply feeling it with the back of the hand, or by using an air current detector, also called a smoke pencil. This handheld device produces puffs of neutral buoyancy smoke that visibly show where air is flowing into the house. With the blower door still running, the team may use an infrared camera to help them see where air and heat are leaking into the home. The infrared camera produces images called thermographs that show heat surface variations in different colors. With the blower door exaggerating heat leakage, the team can use the IR camera to look at walls, windows, and ceilings and read the color differences to detect air leaks. For accurate thermographic images, the temperature difference between the air inside and outside the home should be 10 degrees Fahrenheit or greater. The research team may conduct a duct blaster test. The duct blaster tests the air leakage rate of forced air duct systems. The purpose of a duct system is to convey heated or cooled air from the central furnace, heat pump, or air conditioner to the rooms where it is needed. Typical systems with ducts installed in attics or crawl spaces lose from 25% to 40% of the heating or cooling energy that passes through them. The duct blaster equipment consists of a small fan, similar to a blower door fan, and a pressure gauge. The duct blower is attached to the duct system at the largest register in the home or at the air handler. The retrofit team will seal all of the other registers in the house. The duct blower fan is turned on and its speed is adjusted until the pressure in the ducts reaches a standard value. The greater the volume of airflow needed to maintain this pressure value, the more leaks there are in the duct. The equipment can also be used to measure airflow at each duct register with a pressure pan test. This test can help the team identify ducts that may have been disconnected or blocked. The team will analyze the data collected during the checkup and the last 12 months of your energy bills using energy analysis software. Then they will schedule a meeting with you to present the results of the analysis and discuss recommendations for upgrades to your home. The recommendations might include air sealing, increasing insulation, installing new HVAC systems, replacing appliances and windows, and changing lighting. Based on your budget and goals, you will decide which upgrades you want to make to your home. The team may be able to recommend qualified contractors for specific upgrades. Tax credits, rebates, and financing options can make these upgrades more affordable. Check with your local utilities to see if any of these options are available. You may also want to visit DOE's DSIRE USA website for information on state, local, utility, and federal incentives. The team will meet with you and your contractor to discuss the goals of the upgrade and oversee the installation to ensure that it is done correctly. When upgrades to your home have been completed, the research team will complete the last phase of the home energy checkup, the post-checkup. The team will repeat the visual inspections, blower door and duct blaster tests, and combustion safety testing to make sure that your home is performing as it should. The final testing verifies that the recommended upgrades have improved your home's performance and that health and safety standards have been met. The retrofit team will provide you with a written report summarizing the improvements, test results, and the estimated energy savings. The Home Energy Checkup is part of Building America's Deep Energy Retrofit Research Project. The Pacific Northwest National Laboratory manages this research for the U.S. Department of Energy and coordinates the project with other DOE research partners and teams throughout the United States. To date, deep energy retrofit researchers have performed checkups and upgrades for at least 50 residences across the nation. For each home, the research team identifies a package of cost-effective technologies and strategies to reduce energy use by more than 30%. A deep energy upgrade usually requires an investment of $5,000 to $20,000. Rebates, tax credits, and low-interest loans are often available to help homeowners pay for home upgrades. Homeowners and contractors draw on the researcher team's expertise as they select and implement the upgrades. Once upgrades are completed, the researchers measure energy savings and improvements in comfort, health, and safety. Analysts will use the data to evaluate benefits and cost-effectiveness of deep energy upgrades. These analyses will inform the U.S. Department of Energy's best practices for upgrading homes in climate zones across the country. For more information about the Department of Energy's Building America program and Deep Energy Retrofit Research Project, contact the Pacific Northwest National Laboratory.